putting quantum mechanics and electron configuration, orbital theory, all that into practice. Write the condensed electron configuration, also known as noble gas, for CO plus 3. Draw the orbital box diagram for the outer electrons. Describe the magnetic behavior. So I know magnetic behavior, we talked about two terms, dimagnetic and paramagnetic. Dimagnetic is when there's paired electrons, and paramagnetic is unpaired electrons. And that affects the magnetism of these different elements, specifically the ions. So how they react to an external magnetic field if the electrons are paired or unpaired. So let's first start with writing the electron configuration. We have CO plus 3. I always like to first write the original element before the ion, just personally. So for CO, I have, if you all have a periodic table handy, the noble gas before is argon. And then 4s2, 3d, 1, 2, 3, 4, 5, 6, 7. Great. Now 3 plus means I lose 3 electrons. Now these 3 electrons do not go from the d orbital first. They are first going to go from your outermost shell, which is the 4s. So 4s2 is gone now, but then you still have one more electron. So your electron configuration for argon, for chromium plus 3, would be argon 3d6. Another way to think about this is, okay, well, this is CO. What if I had CO plus? Then I would have argon 4s1 3d7. Now if I have CO plus 2, then I would have argon 4s is gone because I lose another electron 3d7. Now 3 plus, then now I have to take from my 3d orbitals because that's my next outermost electrons. Draw the orbital box diagram for the outer electrons. I just have my d orbitals. My d orbitals have 5 orbitals, so I'm going to write 5 boxes, 3d. So 6 electrons. You first place 1 electron, spin up in each orbital. 1, 2, 3, 4, 5, and then pair, 6. So you have 1 pair and 1, 2, 3, 4 unpaired. Now you see, all right, is this dimagnetic or paramagnetic? Well, there's unpaired electrons, so this is paramagnetic. Now looking at the next question, if n is equal to 4, what are values for all different quantum numbers, and what are their physical meanings? So if n is equal to 4, L is equal to n minus 1, which is 3. So I have 3, 2, 1. So when L is equal to 3, I have my d orbital. When L is equal to 2, I have my s orbital. And when L is equal to 1, I have my, this is my p, and then my, whoopsies, s orbital. So these are my different quantum numbers. If we just look at the outermost layer, I would say, okay, so when n is equal to 4, L will equal 3. M sub L will then be -3, -2, -1, 0, 1, 2, and 3. And my M sub S will be +1/2, -1/2. So what these mean is my n quantum number, that gives me my size of my orbital, the energy level. My angular momentum, L, gives me my shape. Then my M sub L will give me the different orientation. And my M sub L gives me the spin of the electrons in the orbitals, where these quantum numbers define which energy level, which orbital, how many orbitals, and exactly the electron spin. So for example, here I'm an energy level 4. I have a d orbital I have 5 d orbitals, and then I have the electrons that will spin up and